Okay, so when we balance equations, we're applying the law of conservation of mass. Atoms can't be created or destroyed within the chemical reaction. So what that means is everything on this side has to add up to the same thing on this side. Even though we have different configurations, we should still have the same number of atoms. So if we look here, we have 2 mercuries and 1 oxygen. On this side we have 2 mercuries and 1 oxygen. Okay, so we can change the coefficient in front, meaning that we multiply this entire molecule by 2. Then over here we have our entire molecule multiplied by 2. But here we have O2. Okay, so 2 times Hg. O is going to be the same thing as 2 times Hg and 2 times O. When the reaction occurs, we still have 2 Hg's or 2 mercuries, and then the oxygen comes out as that diatomic molecule. Okay, so we can change those coefficients, but we cannot change the subscripts. Alright, so this little chart just shows us the meanings of these different subscripts. So if we just have the element symbol, that means we have 1 atom of that particular element. If we have a subscript, that means we have that element, but it's bonded together within the molecule. And then here we have 2 different elements bonded together, so we write them like this. And here we have 1 carbon and 2 oxygens bonded together. And then if we have a coefficient out front, that means we have 3 of those molecules. Okay. Alright, so stepwise balancing procedure. So the way they do this is they have you create an inventory of what's going on, and you use that inventory to figure out how you need to change the reactants and the products. Okay, so first you're going to write the unbalanced equation. So calcium, let's see, calcium bicarbonate, and this means it's an aqueous in a solution of water. And here we have sodium carbonate, again, in solution of water, and that's going to give us sodium bicarbonate, and then calcium carbonate. So this again is in solution. This precipitates out as a solid. Okay, so that's not too big of a deal. Let's carry on here. So we inventory the numbers of each kind of atom. So calcium, we've got 1 calcium. On this side, we have 1 calcium on this side. We're going to write that in our chart. And then we have 2 bicarbonates. Now what in the world? Okay, so this is what we call a polyatomic ion. It's an ion bonded with that calcium, but it has more than 1 atom in that ion. So this actually moves as a unit, almost like it's its own little element. Okay, so you can see how it's here, and then it moves over here to the sodium. Okay, so we're going to count that polyatomic ion as itself. Okay, so HCO3, we have 2 of those here. HCO3, how many do we have? Well, just 1. Okay, so we're going to know we're going to have to change that. Okay, we look at our sodiums. We have 2 sodiums here, 1 sodium here. Alright, so again, we have an issue. We'll have to fix that. And then our carbonate, again, another polyatomic ion. So CO3, CO3, so we have 1 of each of those. Alright, so what are we going to do with that? Well, let's move along here. Okay, so placing a coefficient of 2 in front of sodium, what is that, bicarbonate, will balance the equation. Okay, so let's see if that's true. So if we put a 2 here, so 1 calcium, 1 calcium, and then HCO3, we've got 2 here. If we put a 2 here, Maybe so, because that would give us 2 HCO3s. Then 1 sodium, 1 sodium. Okay, 1 carbonate. I'm sorry, 2 sodiums. And this is going to have a 2 in front of it now. So 2 sodiums, 1 carbonate, 1 carbonate. So it looks like it's going to work. Alright, let me do this. I'm going to kick over here to my notepad, and I'm going to write this equation out where we can see what's going on. Let me delete my chicken scratch here. Alright, so we have Ca HCO3 2 plus Na2CO3 and that's going to produce NaHCO3 plus CaCO3. Okay, so whenever I do this on my own, I don't necessarily make that inventory. What I do is I start over here. Okay, so I have 1 calcium. Okay, 1 calcium, 1 calcium. Okay, and then I've got 2 HCO3s. Just 1 HCO3. So I'm going to go ahead and stick a coefficient right here. So now my HCO3s are balanced. 2 HCO3s, 2 HCO3s. Okay, so now let's go to the next element. We have sodium, Na2. We've got 2 sodiums. So now we have a coefficient in front of this, so we have 2 sodiums here. We have 1 CO3, 1 CO3. So the equation is balanced. It's just a different way of taking that inventory. Now some equations are a little more complicated, some are easier. I'm always surprised that the text uses this polyatomic ion for the introductory example. But you just treat it like you would an element all by itself. Alright, let's kick back over here to PowerPoint. Alright, so now what we want to do is we want to generalize equations, because there's different kinds of equations different kinds of reactions that happen in with different elements, but they kind of do the same thing, if that makes any sense. Okay, so first off, we're going to look at a combustion reaction. So we hear this term combustion. Well, what does that really mean? Well, combustion means that we have a hydrocarbon, which is carbon and hydrogen, and it's in the presence of oxygen, and that's going to react and produce carbon dioxide and water. So basically, you're burning a hydrocarbon fuel. So when you do that, notice here we have methane, CH4. That would be the same thing that's in natural gas that burns, and it burns so cleanly. Okay, so CH4 plus oxygen, that would be the oxygen that's in the air, and that's going to produce carbon dioxide and water. So anytime we have a hydrocarbon, we react it with oxygen in a combustion reaction. We produce carbon dioxide and water. Here we have C3H8. Okay, so not sure what C3H8 is. I think it's propane. But anyway, regardless, it's a hydrocarbon. We're reacting it with oxygen, and we're going to produce carbon dioxide and water. Okay, that is a combustion reaction. Okay, so I'm going to end this one here, and then we're going to pick back up on the next one.